Good morning, everyone. Today I will present about the Sunway City Eco Mall, located in Tambun, Perak. This project is a major shopping mall development. It covers about 18.88 acres, and the total investment is more than 1 billion ringgit. And the mall is planned as a 6-story commercial building with 4 main retail floor and basement parking. It can provide around 2,800 to 3,000 parking space. The mall is expected to be complete in 2027, and when it's complete, it will become the largest shopping mall in Perak with around 350 retail lots, and it will also include facilities such as an ice skating rink, bowling center, indoor sport arena, cinema exhibition center, and dining area. For the third party involved, the developer is Sunway Berhad. The client is Sunway Lost World Waterpark Sdn Bhd, and the main contractor is Sunway Construction Sdn Bhd, and the architect is SA Architect Sdn Bhd. For the technology involved and the software partner is handled by Glodon Sdn Bhd. For the type of soil at the site is quite challenging because it is near the limestone hills and the former mining lands. The site may have karstic limestone, mining slime, sand tailing, and alluvial deposit. This soil can be weak and uneven, so proper soil investigation and foundation design are very important. In conclusion, Sunway City Mall Ipoh Mall is an important commercial project in Perak. However, careful construction planning is needed because of the difficult ground condition.
So next, proceed to the construction methods for the Sunway City Eco Mall, which are designed to ensure both safety and sustainability, especially since the site is on ex-mining land near the Asian limestone hills. So the process begins with the site preparation, where the seep trap and waterways are installed to control erosion, and the geotechnical checks are done for cavities or sinkholes detection. The next stage is bulk excavation, which is using excavator for cut and fill operation to form platform for the mall, cinema, and basement parking, with the soil reused for landscaping. So next, slope are stabilized with soil nailing and sheet piling. So next is compaction, which carry out using vibrator roller with a soil compaction in layer and test for a strength, while rainwater is diverted into harvesting system. The last stage is substructure works such as pipe caps and basement slab are excavated, coordinated through building information modeling, or known as BIM, to ensure accuracy and integration with drainage and structural planning. For the Sunway City Eco Mall project, special materials are used to handle the difficult limestone terrain. So a few materials that I've mentioned is crushed granite for stabilization, and steel sheet piles with soil nailing used to support during excavation. Heavy machinery is also used, which is hydraulic excavator for bulk excavation, backhoe loader for digging and backfilling, tipper trucks for transporting soil and material, and hydraulic breakers for break hard rock. And for difficult hard rock, they use explosion to break the rocks. So together, this material and machine ensure smooth progress under challenging ground conditions. So together, this material and machine ensure smooth progress even under challenging ground conditions. So proceed to testing. Testing is a crucial part of the project because the site is located on ex-mining land, which are often contains cavity and sinkhole. So several geotechnical tests are carried out to confirm soil strength and safety. The standard penetration test (SPT) and cone penetration test (CPT) are explore the soil profile and identify a weak zone. Plate bearing tests measure the soil's bearing capacity and settlement under load, while dynamic compaction tests to improve soil strength by reducing voids in loose ground. Other testing is laboratory soil tests to perform to check moisture content and particle size distribution. Enterbed limits and compaction level ensure the soil is suitable for engineered fill. So together, these tests provide confidence that the foundation can safely support the heavy structures of the mall. For the safety procedure are equally important. The project follow ISO 54001 and Sunway Group or OHSE standards. Before a work begins, geotechnical investigation are conducted to avoid landslide or collapse, and the digital tools like Autodesk Construction Cloud, or called as ACC, are used to stimulate potential hazard. Heavy machinery is inspected regularly and operator must hold valid competency certificates. On site, whole roads, speed limits and loading zones are clearly designated to reduce accident. Slopes are stabilized using dancing, shoring and daily monitoring to prevent crash collapse. So for environment protection, the dust is controlled with water tanks, temporary drains reduce erosion, and waste is managed through the CR hierarchy, which is prevent, reduce, reuse, recycle, recover, and dispose. The vehicle use Euro 5 diesel to minimize emission, and strict guidelines from Department of Mineral and Geoscience are followed to protect the nearby limestone hills. The method used in the Sunway City Eco project are highly effective because they combine different foundation systems to suit the difficult limestone and mining terrain. Soil nailing, steel sheet piles to stabilize the ground and minimize risk of sinkhole cavities and uneven soil strength. This variety of techniques ensure that the heavy structure of the mall can be safely supported. So operational efficiency is also achieved by optimizing the use of machinery. The contractor reduced the number of rigs upgraded to newer high efficiency equipment and improve productivity on site. So this allows the foundation works to be completed faster, keeping the project on schedule and reduce downtime or delay. In terms of cost, the overall development is valued at 1.2 billion, making it one of the large projects in Perak. So outside of this, 721 million is allocated for the mall main construction works, while 40 million is dedicated to earthwork and geotechnical investigation. This early investment was necessary because of the challenging limestone terrains and its mining rate. The earthwork costs covered by the excavation, deep basement excavation, diaphragm walls, piling work, soil treatment, dewatering and erosion control. By spending on this critical area upfront, the project ensures a safe foundation construction and reduce geological risk, which is essential for long-term stability. So last but not least, for case study 1, which is the problem and solution during earthwork. So during the earthwork for Sunway Ipoh Mall, several major challenges were encountered. The first one was the limestone soil and rock formation, which made excavation difficult due to large and even rocks and hard strata. To solve this, heavy rip specialized trenches and controlled microblasting were used to break the rock into manageable size while minimizing vibration and overbreak. The second challenge was the karst topography, which irregular bedrock, step cliff, cavity and sinkholes. So engineers address this by conducting subsurface mapping, core drilling and applying soil stabilization methods such as soil nailing, micropiling and grouting to strengthen weak zones. Another issue was equipment downtime and reduced productivity caused by road trade. This was solved by upgrading to newer, higher efficiency rigs and applying predictive maintenance to reduce wear and tear. So environmentally and community impact were also concerned as dust, noise and vibration affected nearby residents and the loss of tambur. To mitigate this, water space and dust suppression system were used. Acoustic barriers were installed and noisy operation were restricted to daytime hours only. Last but not least, last problem is extreme weather and supply chains risk post delays, especially during heavy rainfall when site becomes waterlogged. So the contractor implements a proper drainage system, flexible timelines and use virtual design and construction called as VDC planning to visualize and coordinate the work more efficiently.
Okay, we meet again. Today, for this slide, I will talk about case study 2 project background, which is the Class C Government Quarters project located at Jalan Abdul Rahman, Muar Johor. This project involved the construction of new residential building. It also includes external work such as access road, drainage system, utilities, service, and landscaping. Before construction start, work must be done first. Work include removing unstable soil, excavation, filling, soil compaction, and site leveling. This work is important because it prepare a stable base for the building. If a work is done properly, it can improve soil strength, reduce settlement, and improve the drainage. If it's not done correctly, it may cause foundation problem, cracks, and high maintenance costs in the future. The contract sum for this project is about 1.8 million ringgit, and this cost includes building works, external work, drainage, road work, mechanical and electrical work, landscaping, and other related works. For the party involved, the developer is JKR Johor, the main contractor is Holding Builders Sdn Bhd, the architect is Architect JKR Johor, the civil and structure engineer is Dominic Mega Venture, the quantity surveyor is JQS International Sdn Bhd, and the mechanical and electrical engineering is Setia Electrical Engineering Works. The soil at the site is mainly residual clayey soil with some sandy clay layers. This soil is suitable for low-rise building if it is properly compacted. However, it can hold water during rainy season, so moisture control is important for this. The topsoil must also be removed because it contains roots and organic matter. In conclusion for this project needs proper works and soil compaction to make sure the building is stable and safe.
Assalamualaikum and hi, my name is Hassan Inaki bin Aslan, and now I am going to continue with the construction method. So firstly, it begins with site clearance, where vegetation, trees, debris and unwanted structures are removed to prepare the site. Next is topsoil stripping, where 150 to 300 mm of organic topsoil is removed because it is not strong enough to support the building. This topsoil is kept and reused later for landscaping. After that, the surveyor carries out the surveying and setting out to establish the building lines, boundaries and formation level based on the approved construction drawings. Excavation is then carried out using hydraulic excavators to reach the required foundation depth. Any weak or unsuitable soil is removed from the site. Once excavation is complete, approved fill material is placed in layer of 200 to 300 mm until the required ground level is achieved. Each layer is then compacted using rollers or plate compactors, and then finally grading is carried out to create level surface, ensure proper drainage and prepare the site for foundation construction. Now we are going to move on to the material, plant and machinery use. Several types of plants and machinery are used during earthwork to improve productivity and complete the work efficiently. Hydraulic excavators are mainly used for excavation, while bulldozers are used for site clearing and rough grading. Backhoe loaders handle smaller excavation works, and dump trucks transport excavated soil and imported fill materials. Motor graders level the ground to the required formation level. Vibratory rollers and plate compactors compact the soil to improve its strength and reduce settlement. Water browser supplies water to achieve the optimum moisture and content during the compaction, while total stations are used for surveying and safety out. In terms of the material used, imported granular fill is placed to achieve the required ground level because it has good drainage and can be compacted easily. Selected backfill material is used around foundations and trenches to reduce settlement. Crushed aggregate provide additional ground stability, while geotextiles reinforce with soil and prevent soil mixing. The removed topsoil is stored for landscaping purposes, and water is used throughout the compaction process to achieve maximum soil density and ensure long-term ground stability. Now for the testing, several laboratory and field tests are carried out to ensure the earthwork meets the required engineering standard. First, the standard penetration test or SPT is conducted to determine the soil strength, density and bearing capacity, which helps engineers select the appropriate foundation. Next, the moisture content test measures the amount of water in the soil to ensure it is suitable for compaction. And then the Proctor compaction test is then performed in the laboratory to determine the maximum dry density and optimum moisture content of the fill material. So during the construction, the field density test checks whether the soil has achieved at least 95% of the maximum dry density required by the project. Finally, if necessary, a plate load test is conducted to assess the ground's bearing capacity and ensure it can safely support the building foundation. And then, in terms of safety procedures and environmental, safety is very important during the work because the work involves heavy machinery, deep excavation and moving vehicles. All workers must wear personal protective equipment such as helmet, safety boot, gloves and reflective vests. Excavation deeper than 1.5 meters must be supported with shoring or safe slope to prevent collapse. Heavy machinery should only be operated by trained personnel, and warning signs, barriers and traffic routes are provided to ensure a safe working environment. The excavation slopes are also inspected regularly, especially after heavy rainfall. Environmental protection is also important during the work. Water is sprayed to reduce dust, while temporary drains and silt traps help prevent soil erosion and water pollution. Construction machinery is maintained to reduce noise and exhaust emissions. Excess soil is disposed of at approved site, and existing trees and exposed slopes are protected to minimize the environmental impact. So for the effectiveness of the method, it uses modern machinery for faster and more efficient work. Layer by layer compaction improves soil strength, reduce future settlement and foundation problems. Accurate surveying and ensures correct ground level. Proper grading improves surface drainage, provide a stable and safe foundation for the building, and improve construction quality and save time and cost. So, and then we're moving on to the cost involved. So for the cost involved, the estimated contract sum for this project is around RM 1.8 million ringgit, and the estimated work is RM 180,000 ringgit, which is about 10% of the total project cost. The largest cost is imported fill, accounting for 25% or RM 45,000 ringgit, because it includes the purchase, transportation and placement of the fill material. Excavation is the second highest cost at 20%, which is around RM 36,000 ringgit, and followed by compaction and machinery operation, which each account for 15%, which is RM 27,000 ringgit. And then other costs include site clearing, disposal of unsuitable soil, testing and quality control, and environmental protection measures. And finally, we have come to the problem and solution of earthworks. Several problems may occur during the earthwork construction, but each problem has an appropriate solution. First, soft ground can reduce the soil's bearing capacity, so unsuitable soil is replaced or reinforced using geotech style. And then poor compaction may cause future settlement, so the soil must be compacted layer by layer with the correct moisture content. And then the water accumulation during heavy rain can delay the work, so temporary drains and dewatering pumps are used. Soil erosion is controlled using silt fences, erosion blankets or turfing to protect exposed slope. Another issue is the slope failure, which can be prevented by providing safe slope angles or installing shoring system. After that, we have weather conditions, especially heavy rain, may delay the construction, so proper scheduling and site protections are important. During the dry weather, dust pollution is reduced by spraying water and covering transported soil. Finally, machinery breakdown can delay the project, so regular inspection and preventive maintenance are carried out to keep the equipment in a good working condition.
This comparative study evaluates the earthwork techniques used in two construction projects, the Sunway City Ipoh Mall currently under construction and the Class C government quarters in Muar Johor, which have been completed. Although they differ in size, soil condition, construction technology, complexity and cost, both projects involve similar earthwork activities. For similarities, both projects follow the same earthwork sequence, starting from site clearing, excavation, filling, compaction, grading, and formation level preparation to ensure stable ground before foundation work. They also conduct geotechnical investigation to assess soil condition. Heavy machinery like excavator, roller, grader, and dump truck is used to improve efficiency, while workers wear PPE for safety and machinery is regularly inspected to prevent breakdown. Temporary drainage and dust control measures are also implemented to reduce environmental impact, such as soil erosion, stormwater runoff, and construction waste. Next, for differences, the Sunway City Ipoh Mall is a large commercial project, while the Class C government quarter is a small residential project. The mall is constructed on unstable ex-mining land, whereas the quarters are built on more stable residual clay and sandy clay soil. As a result, earthwork at the mall is more complex due to issues such as sinkholes, cavities, and weak ground condition. In terms of planning, the mall uses building information modeling BIM for better coordination, while the quarters rely on traditional surveying method. And for ground support, the mall applies soil nailing and steel sheet piling for deep excavation, where the quarters use stable excavation slope and geotextile fabric to improve weak soil area. Next, for efficiency and effectiveness, for case study 1, the project used different foundation systems such as deep board pile, pad footing, and micro pile to suit varied limestone conditions and ensure safe support despite cavities and weak ground. Soil nailing and steel sheet piling were applied to stabilize deep excavation and prevent soil collapse. Never-failing equipment was used to improve efficiency, reduce breakdown, and keep the project on schedule. Construction planning was optimized by matching foundation method to ground condition instead of using a single approach, reducing risk. Temporary drainage system and retention point were also installed to control stormwater, prevent flooding, and manage construction site while protecting the environment. And for case studies 2, hydraulic excavator and vibratory roller were used to speed up earthwork and reduce manual labor, improving overall productivity. Soil was placed and compacted in thin layer to increase strength and prevent future settlement, while compaction quality were closely controlled to ensure a stable foundation. Accurately surveying and grading method were also applied to achieve correct ground level and reduce construction error. Overall surface drainage was designed through finer grading to prevent water ponding and protect the foundation. Overall, conventional earthwork method were used, making the project cost efficient while ensuring good quality and long-term stability. For cost analysis, the earthwork cost for both projects is very different due to size, soil condition, and complexity. Seri City Ipoh Mall has a much higher cost, about 40 million out of 1.2 billion, mainly due to large-scale excavation, unstable limestone ground, geotechnical investigation, and advanced foundation system. In contrast, the Class C government counter has a lower earthwork cost of about 180,000 because it uses simpler and conventional construction methods suitable for a small residential project. Overall, the mall has higher earthwork costs to ensure safety and stability on difficult ground conditions. In conclusion, both projects show the earthwork method must be chosen based on site condition because they affect safety, stability, and performance. Sunday City Ipoh Mall use advanced methods like board pile, micro pile, soil nailing, steel sheet piling, and beam due to its unstable ex-mining soil. In contrast, the Class C government council use simpler and more conventional methods suitable for stable ground and lower costs. Overall, proper planning and site investigation are essential for safe and successful construction.